So why cloud computing? What exactly is cloud computing and why is it so popular today? What are the benefits and limitations of cloud computing? What are the types of systems you can deploy in the cloud? What makes cloud computing such a great thing? And also, what happens when things go wrong in the cloud? What is cloud computing? Cloud computing is a way to quickly deliver computing services over a network. Private cloud services are offered over a private secure network. Public cloud services are offered over the internet. Cloud servers are often provided by massive shared data centers that offer an economy of scale to offer many services that private companies could not offer in their own data centers. Cloud computing has its roots in some early mainframe services that were offered to customers in the pre-2000 era. Many of these services offered a paid service that can be consumed remotely. However, network infrastructure in these early cloud days limited the types of services that could be offered. Salesforce.com, one of the early pioneers with Software as a Service, or SaaS, in 1999. This ability of many companies to quickly implement CRM systems with this type of product. Amazon then followed and launched some of the early Infrastructure as a Service, or IaaS services, in 2006. They have since followed up with a large number of cloud services. Microsoft Azure began its cloud services beginning in 2010. Since that time, all of the leading IT companies now have cloud service offerings. The cloud computing market is projected to reach $127 billion by 2017. So what are the advantages of cloud computing? Cloud computing really offers a utility mode for computing. That is, you only pay for the resources you use, much like a power company. For example, if you have a server running in the cloud, you will probably be charged by the minute. If you do not need that resource 24/7, you can simply turn it off when you're not using it, and you'll not be charged for the operating cost. You will be charged, however, for the storage costs, but these are generally very small as compared to the runtime services. In addition, most cloud systems provide a model where these systems can quickly scale up to meet a dynamic demand. This is a much more cost-effective model to meet the demands of systems that have very dynamic usage patterns. For example, a tax filing system that has peak demands around filing times, this model fits greatly. Another great advantage of cloud computing is they generally offer self-provisioning models where end users can provision servers and network resources very quickly. In most cases, new servers can be built and brought online in a matter of minutes. In the physical server world, this could take weeks or even months. Another benefit of most cloud systems is they offer advanced services for failover and disaster recovery. These are generally add-on fees, but they allow for companies to consume these services very quickly. Many smaller companies can't afford to build a second data center for redundancy. One more advantage of cloud computing is that many providers are compliant with many industry standard certifications such as HIPAA and PCI. This again is cost prohibitive for many smaller companies to achieve this on their own. So what are the limitations of cloud computing? One major limitation of this technology is that you do not have physical access to your data and the servers you have provisioned. Many companies and government organizations require their employees to have access to these physical environments. This is simply not possible for the cloud computing model. If you have systems that have these requirements, you will have to deploy them on servers that your employees have access to. Another limitation is that in many cases you do not control all of the network resources necessary to connect to the cloud system. If there's a problem with the network, you'll not be able to access your resources. So even if your systems are running, they're no good to anyone if you can't connect to them over a network. Another concern for most companies and government agencies is that security for these systems is provided by a third party that you do not directly control. This makes many companies nervous enough not to adopt these systems. This risk can be mitigated by putting provisions in the service provider's contract to enact penalties in cases of service failures. Also, many companies are now adopting a hybrid model where some of these resources reside in an on-premise data center and the remainder reside in the cloud. In this way, they can pick the environment that best suits the system in question. So there are three major types of cloud computing systems. They are Infrastructure as a Service, or IaaS, Platform as a Service, or PaaS, and Software as a Service, or SaaS. I'll explain each of these in detail. Infrastructure as a Service, or IaaS, is a way to provide virtualized resources over the internet. In this model, you can quickly provision servers, routers, network resources, and really anything you want to build in a complete data center in a cloud-based system. In addition, many of these systems provide scripting languages or other resources, so much of this work can be automated. This allows companies to cut down on the amount of labor required to maintain their server infrastructure. These systems also provide advanced network services such as dynamic scaling. For the next one, Platform as a Service, or PaaS, allows customers to build and deploy applications without the complexity of building physical infrastructure and configuring software. For example, on Microsoft Azure, you can provision a Microsoft SQL Server database as a service. This database service, you do not need to build the internal servers or install software. You simply need to load your database with tables into the system. However, with most of these types of systems, some type of rework is often required. Many companies look at these types of services when building new systems or performing major upgrades to older systems. Software as a Service, or SaaS, allows organizations to consume entire hosted applications over the internet or private network. With this model, there's no software to install or maintain, and the vendor takes complete responsibility for the entire system. There are many examples of this model in the market today. Office 365 from Microsoft is this type of model. Although you can install Office locally on your computer, there are also cloud-based versions of the product that allow you to run Office in a browser. In addition, data can be stored in the cloud on OneDrive, and your email is also stored in the cloud as well. Other examples of SaaS vendors include NetSuite, a major ERP vendor, and ServiceNow, which is a cloud-based service and ticketing system for IT shops. This figure represents the development life cycle of a typical cloud computing system. You will first develop a piece of software on your local development server using whatever software tools your organization uses. In this class, we'll be using Visual Studio. Once this software is developed and ready to go, if you do not have a cloud account, you can next sign up for an account at this time. Next, you'll deploy the system to some newly provisioned cloud resources. After configuring this, then you can point external resources to this system, such as DNS, that will point to your newly provisioned system. These steps are much quicker than using a traditional data center that may take weeks or months to perform these same steps. You will see from the demos in this class that you can build and deploy these systems very quickly using these methods. In summary, the cloud computing market is rapidly changing. The number of services offered online is rapidly growing. All major IT companies now have cloud-based service offerings. Both corporate and consumer cloud services are growing rapidly. These services offer significant opportunities for developers. In the next lessons, I'll show you how to demonstrate how to get these services up and running with several of these services. So thank you very much, and we'll see you in the next lesson. Thanks again.